Okay, without any further ado, we've got a short talk. This is a 20-minute talk. Jaime Sanchez talking about building an Android IDS on the network level. Jaime, take it away.
Thank you. Hi, hello everybody. As he said, my name is Jaime Sanchez. I'm gonna do this talk about building an Android IDS on network level. I worked for security for about 10 years. I've worked for very national and international companies as a specialist and advisor. In my free time, I enjoy doing research on security, and I work as independent consultant. I'm from Spain. I've talked in other conferences in Spain, like Defcon, in Paris. I'm in the arsenal of Black Hat, and maybe you can meet with me in Defcon on activity. I got a proper handover today. I don't know what happened last night. It's my first time in Vegas. Today, I wake up, I was married with two strippers. No, don't laugh. Don't blame vodka. I know the reason of this. Just blame aliens. I'm sure they forced me to drink. I'm from Spain. I don't like partying. So, you know us. So we have 20 minutes before I get with my lawyers to get divorced. So let's get down to business. The reason of this conference is Android has a great market share. Being popular is not always a good thing, because as the mobile device grow, so the incentive for attackers that are looking for new business model. There are over 100 million Android devices. It was from just last year, and have a market share of nearly 50%. And there are several techniques that are used to detect malware and detect attacks for mobile phones, but I haven't seen any open source tool to detect and create patterns to locate this kind of attacks. So we have, in the last years, we have seen several exploits, like the USSD exploit, several vulnerabilities for WebKit. There are targeted malware attempting to steal credentials, emails, and now there is a interpreter for Android. So I had to deal with this, and I tried to make my first approach to solve this. And I took my Android mobile phone, and I make a VPN tunnel with my computer. So I was trying to analyze all the traffic passing through my device. I launched this node on my computer to detect suspicious traffic, and I could also use tools like TCP-dump and make all the analysis on the forensic I could. But, well, this kind of IDS sucks, man. I have several problems because I have to take the traffic from my mobile phone to my computer. That's a waste of bandwidth. I couldn't act like an IPS. I could detect all the attacks. I could detect all malware, but that was just after it happened. So that has no sense for me. There are a lot of signatures for Snort. There are signatures for emerging threats, but they are not so related with Android. So the other fact important is that we don't have any real-time notification for the user. So the user doesn't even know if an attack is happening or is infected by malware or anything. So I continued with my life. I made a program called OS Fuller that it's a practical approach to defeat remote fingerprinting. It's for active and passive fingerprinting, and it takes advantage of a special target of IP tables called Q. And that's where I came with the idea of how to solve this problem. With this tool, I was able to modify in real time all the traffic that was passing through my computer. So I found a problem that was that the packets I want to capture are in kernel space. So the kernel, the extension, and the device driver right inside the kernel space, and I couldn't take that packets to modify in real time before the computer has it. I have to work in user space, so I have my own virtual memory, and I have no other option. So for this approach to work, let me show you a little bit of the travel of a packet from the network card to the application. I call it how I measure packets. So the first thing, when the kernel takes a packet, put inside a 5-step process. The first one is taking directly from the network interface card and put inside a buffer. And then it calls to, with a software or hardware, IRQ, calls the CPU, letting him know that there is a new packet. But the special thing here is that before it gets processed, we have to pass through the chains of IP tables. I'm sure everyone knows the typical target destination like accept or dropping. But here is the special thing I found to make my IDS and my tools. Just after the IP tables, the packet gets through the IP layer, TCP layer. It has some checks on the headers, and then the kernel put inside the application and to the corresponding socket. So, as I told you, we have several targets for IP tables. You know, you can accept packet, you can drop the packet, you can let the remote computer know that you have dropped the packet, but there is a special one that is called queue. That means pass the packet from kernel space to user space. So a little of theory is that this queue delegates the decision of packets from kernel space to user space. So in user space you must have a listener that takes care of every packet. That's because you have to issue a verdict for each packet. You have to accept it. You can drop it, but you can modify in real time before it gets into the TCP IP stack. You have to be very fast because if the queue gets full, all the other packets that you receive will be dropped. So, for summary, I'm capable of processing all incoming and all outgoing traffic inside my device. I made my tool, and I have to do some proof of concept for Android. So I thought I was able to make a tool like this. If I'm able to issue verdict for every packet, maybe I'm not also acting like an IDS. I'm acting too like an IPS. So the first release of my tool was in Perl. Then I moved to C. Then I moved to Python. Then I moved to C again. So who cares putting in this technology again? And then I get to Android IDS. This Android IDS is a first approach to create an open source software that it's a network IDS and a network IBS that has to perform real traffic analysis and packet logging on the internet protocol. It's some features and things. As you said, it's like protocol searching, or protocol analysis, content matching, and content searching. It would be great if you were capable of hooking to the syscalls of the Android device. I'm working on this because you could reduce the amount of false positives. But there is some problems finding the address of the table. There are differences between the different versions of Android kernel. So this is something I have to work on. So the architecture of the IDS should be a sensor and should be a server. The sensor is installed inside our Android mobile device and run without human interaction. It's responsible for analyzing traffic. It should send some push message to the mobile device so the user can know if it's having an attack or installed malware. So I done this with an application you will see that's called Notify My Android with the IP, and I send the real-time notifications. So it reports through the login server if you want. You can do it by syslog. You can create a VPN tunnel, and it should do some custom reactive actions like dropping the packet, adding new rules to the IP tables, or launch several scripts, as we will see. And very important is that it should impose minimal overhead to the device. On the other side, we'll find the server. The server is a Linux box. It's only responsible for taking all the traffic. It should send the signatures, the updated signatures to the device, and store the events in the database. Another feature is that we can do the statistical analysis of the packets in the server instead in the mobile device because of the power of the computer. And we can use any CM or whatever you want to add IP reputation and correlation for the attacks. So the first thing I had to do was protocol analysis. It's my day by day. So the anomaly packets, you know, there are some packets that do not conform the standards or have several errors in the headers. And most of the devices in the network will almost drop them. This kind of packets you can find in denial service attack, in scans, in worms, in virus, and several of them have some anomalies because of programming with raw sockets. So, as example, you can see now that there is a TCP/IP packet. It has several flags activated. This kind of packet belongs to a network scanner and should be dropped, and it should be reported to the server. So, as I told you, I have a tool. It was called OSFuller. It was for defeating active and passive fingerprinting. So, the first thing I have to do is like porting all my code because my tool was working okay. So, I was trying to detect and drop packets from well-known tools. In this case, Nmap is 16 proofs, TCP, IDP, and ICMP. And I will show you how it detects the attack. In this case, you're seeing that we are connected through a VNC to the mobile. We have to have the device rooted because we need to access to the IP table chains. In this case, we are launching the IDS. Is in login mode. You can see that it's logging almost every packet that has come to the mobile device. And if you see, when it finishes now, the Nmap has detected that it has like a Linux box 2.6 or 3.0. In this case, we have only logged all the attacks. It has a notification. It's disabled not to stop the demo. And in this case, what we are going to do is to use the IDS to fool this kind of fingerprinting. We have activated it, and it's in drop mode, so every packet is being dropped, is being reported to the central server, and it's sending full packets to the attacker. You have seen now, it's a Sony Ericsson telephone. It's based on Linux 2.4. But it works with any other signature. I have to work on this release. And now you can see that through the Notify My Android, you have like the two alerts. One is for login, you have been scanned, and the second one is that we have put the IDS in drop mode and it's fooling the scans. So the next thing I have to take care was pattern matching. I don't work for NSA, so I have to work by myself to capture all traffic and look for a fixed sequence of bytes inside almost every packet. This is a problem because some of the attacks are related to a well-known port, and if we have to inspect almost every packet, we can have some false positives. This can be solved by using stateful packet matching, but I'm still working on it too because I want to search for a pattern through several packets, and it's the only way to make it work. So another thing I have to deal with was the signatures. There are some signatures from emerging threats for Android, and I have to run a script to convert that rule from Snort to our format. In this case, it's only convert Snort-friendly rules, and it can only, as we have seen, we can only search for a specific pattern in for a specific string in every packet. We should work with preprocessors. We should analyze all the flow, but still working on it. Some of the things, the exploits we have seen is the USSD code. The USSD code is a code that is entering into your phone to perform some actions. It's used by the network providers to give the users some access to some service like call forwarding and other SIM functions. It's very simple. It links the browser to the phone application. That means that when you get into the web application and you have this code, the phone without human interaction will show you the telephone application. So this exploit was published 1 year or so ago, and we have several web signatures, and we can detect it. In this case, I have the demo, I have to cut it down, but it has detected a WebKit code exploit, an Android browser remote crash. You can detect the payloads, you can detect almost everything that you want. The last thing I wanted to deal with was the malware. There are a lot of malware for Android. Almost every malware has a pattern. I've searched, in this case, is the SMS send. You can download it from here, and when you get downloaded, it connects to the command and control server. You can find the string that it's using to connect to the remote server, and the string to find that packets is the rq.php. We could just do those proofs, and we can do everything. If we have the pattern the malware is using, we can detect almost every malware we have. And not only detecting it, we can drop all the traffic that it's sending. On the other side, we have the meterpreter. Meterpreter, I thought you know, it's an extensible payload for Metasploit. It communicates over a stager socket, and it has some features like command history, tab compension, some channels, some mod. So now there is an Android version. What I have done is creating a package for Android, installing inside my own system, and try to detect all the traffic that it's having. So the processor is the same. We have to get inside our Android device, we have to be root, and we should launch the script. In this video, there is no. We can see how was the software installed, but there are several methods for signing this kind of malware, and it will only have to take a listening socket for Metasploit and just connect it back from the Android device. So now we're waiting till the socket gets open. And when it does, what we're going to see is just connect and see if we can detect all the traffic it's passing. So just push the button, and we have found it. We can see that there is several commands that it sent from the Metasploit to get the system information and so. And we have several commands. We are running it one by one. And when you decode the channel, it's very easy to find which command is being executed. And the fun thing is that I couldn't done a proof of concept now, but you can use some kind of honeypot, because you are able to modify the packet in real time. So if you get infected, you can fool the attacker too. You can show whatever directory you want. You can send it pictures when he's asking for the welcome list, or you can send it any audio file when it's trying to attach to the microphone. In this case, you see that it's very simple. You have all the commands, but not only are we gonna log this, we are able to drop the packets too. In this case, I'm not gonna drop all the session. You see that it's working, and what I want to do is only drop the packets related with the webcam. So now you can see that there is no way to access to the webcam, and the IDS is blocking all the traffic. So with this, that's the way I found to create an IDS. You don't have to depend on Snort or commercial appliance that cost like $20,000. You can do it by your own, and the only thing you have to work is in having a great signature database to work with this, because Android devices are the next target for attackers. So that's it. Thank you.